The plot below shows traces for x equals -1, x equals 0, and x equals 2. Looking at the traces, notice how the horizontal axis is the y-axis, the vertical axis is the z-axis. We're asked to identify the equation of the surface. To do this, let's begin by determining the equations of the traces for all four functions. I've already set this up. Here we have the equations for the x equals -1 traces, for the x equals 0 traces, and for the x equals 2 traces. Let's go through one of these. To find the x equals -1 trace, we should x equal to -1 for each equation. And let's use z instead of f of x comma y. So for the first function, we have z equals y squared plus x. If x equals -1, we have z equals y squared minus 1. The next function is z equals x squared plus y. If x equals -1, we have z equals y plus 1, because the square of -1 is positive 1. The next function is z equals y squared x. If x equals -1, we have z equals -y squared. And then finally for the fourth function, which is z equals x squared y, if x equals -1, we have the equation z equals y. Similarly, we have the equations for x equals 0 and x equals 2, which I'll let you check. Let's start with the x equals -1 traces and see which is graphed. Well, here we have z equals y squared minus 1, and again, because this is the y-axis and this is the z-axis, this would be a parabola that opens up, shifted down 1 unit, which is not graphed, which means the surface cannot be the first function, z equals y squared plus x. Let's go ahead and cross this off here, as well as here. Next, we have z equals y plus 1. This would be a line with a vertical intercept of 1 and a slope of 1, which is also not graphed, and therefore the surface cannot be the second function of z equals x squared plus y. Next, we have z equals a -y squared. This is a parabola with the vertex at the origin opening downward, which is graphed here in red, and therefore the surface may be from the equation z equals y squared x. Let's check the next trace. Here we have z equals y. This would be a line with a vertical intercept of 0 and a slope of 1, which is not graphed, and therefore the surface cannot be the fourth function z equals x squared y. So at this point, by elimination, we know the surface must be from the function z equals y squared x. But let's also check the x equals 0 and x equals 2 trace for this function. The x equals 0 trace is z equals 0. The x equals 2 trace is z equals 2y squared. So for the x equals 0 trace, which is z equals 0, this would be a horizontal line passing through the origin of the yz plane, or in this case the y-axis, which is graphed in blue. So this trace is correct. And now let's check the x equals 2 trace, which is z equals 2y squared. This is a parabola that opens upward with the vertex at the origin vertically stretched by a factor of 2, which is this green parabola here. Notice when y is 1 or -1, z is positive 2, which is this point and this point on the green parabola. So this does verify these traces are from the equation or from the function f of x comma y equals y squared x. Before we go, let's also look at this in 3 dimensions. The function f of x comma y equals y squared x is graphed here in green. This blue plane is x equals -1. Notice how when it cuts the surface, the intersection is a parabola that opens downward, which we can also see graphed here on the right in the yz plane. And now let's look at the x equals 0 trace. Now this is the plane x equals 0. Notice how it cuts the surface, which would be the y-axis. This horizontal line does not show on the right though, because it's right on the horizontal axis. The third trace was x equals 2. This is the graph of the plane x equals 2. Notice how it cuts the surface, and the intersection is a parabola with the vertex at the origin that opens upward. It's also been vertically stretched by a factor of 2, which we see here graphed on the right. So this does verify that our work is correct. I hope you found this helpful.